Let's have a look at this event. We've got a red dashed line here, which shows up as a red peak in this Lego plot, which shows that there's some missing momentum, which might indicate a neutrino, but that's not what we're looking for today. We've got a couple of big, long blue tracks going out here into the muon chambers. So one going that way, one going this way, although that one doesn't seem to go right into the outer muon chambers. But that might be because if we look at the side view, we can see that one of these muon tracks is actually going out in a more kind of longitudinal direction, so not going through the outer muon chambers. Then there are a whole load of other tracks in the middle here, and there's a whole load of energy that's showing up in the Lego plot and scattered around the calorimeter here. But there aren't any really obvious concentrated clusters of energy that would indicate an electron or a positron, or if there are, then it's going to be quite hard to distinguish between them and all the other stuff that's in the background. Let's apply the cut again to the transverse momentum. So instead of a threshold of 1 GeV, we're going to increase this to 5 GeV. So we're still keeping the muon tracks, and there's a couple of other tracks, but nothing that really looks like another muon or like an electron. So we can zoom in a bit, just in case we're missing anything, but it really looks like there's nothing else much we can distinguish, but we do have two muon tracks. So let's use the fingertip picking tool again and select one of these muon tracks. So that's the top one in this view, and it's also the upper one in the side view. Looking in the track information panel here, we can see that it's got a positive charge. Let's click the muon button to mark it as a muon, and let's go to the other one. Now let's see what charge that one has. That has a negative charge, which is good because we're looking for things like the Z boson that have a zero charge. So if they have a positive particle coming out, they must have a negative one to match it. So let's mark that one as a muon as well. And then we can look at the invariant mass window and see that it's combined those two muons, and it's said that they have a combined invariant mass of about 83 GeV. So this means that if that pair of muons came from a neutral particle, that neutral particle had a mass of about 83 GeV. Well, this is rather lower than the Z boson mass, which is nearer to 90 GeV, but there's always some spread around that, and of course not every pair of muons does come from a Z boson, but we can't just look for ones that match what we expect. We have to be a bit more fair in our approach. Just take whatever meets our criteria and looks like a pair of muons. So we will include that in our final results that we'll analyse later on in the masterclass.